Right, good morning everyone. Today's video is going to focus on page 20. So before we go into page 20, a couple things that we should kind of review and revisit here. So one thing that we need to revisit is the purpose of titrations. Yes, mainly titrations are used to determine the unknown concentration of an acid or base. But they can also be used to do things like to determine the molar mass of a substance. And that's what we're going to talk about today. And what we need to remember is how we found molar mass in the past. So in the past, we have to remember that molar mass is found, and I'm just going to use mm for molar mass, by taking grams of the substance and dividing it by the corresponding number of moles. And so we have to ask ourselves, how do we make use of this formula? Well, when we did it before, we were given grams of the substance, and we had to do some work to figure out how many moles we had. And that's exactly the approach we're going to use with titrations. So the key here is remembering about our molarity formula. So remember, molarity, capital M, is found by taking moles of our solute and dividing it by our liters or volume of our solution. So if we cross multiply this, molarity times our volume in liters is going to equal moles. So what we can do is actually make a substitution. Because remember, our formula that we use, that's a terrible looking mark. Our formula that we use in our titration calculations is MEV MEV equals MB EB VB. Well, we know M times V is going to be moles. So we can actually substitute in moles on either side of our titration formula. So whether we're trying to get the molar mass of an acid or molar mass of our base, we can substitute moles in for molarity times our volume, but remember the volume must be in liters. And that's kind of our trick to solving these molar mass or mass problems, where we can plug moles in for mass times our volume. But again, volume must be in liters. And then once we get moles, we can plug it into this formula over here. We can solve for molar mass, or we might be asked to solve for how many grams of our acid or base we had. So now that we know kind of how we can do this, by rearranging our molarity formula and plugging molarity times volume into our titration formula, let's try this out. So number one on page 20, if 0.481 grams of our monoprotic acid was neutralized with 20 milliliters of 0.4 molar sodium hydroxide, calculate the molar mass of the acid. So I like to read through this, and I always like to start with what we're being asked. Again, we're asked for the molar mass of the acid. So that means, since we're looking for something on the acid side, that means we're going to substitute on our acid side. So that means instead of M times V, I'm just going to have moles of my acid, so moles of A, times its equivalence. Notice I haven't subbed in or substituted in for equivalence, so I have to leave that in there. I just have subbed in for molarity and volume. So it tells us it's monoprotic, so we know its equivalence is 1. And then let's set that equal to the base side, 0.400 molar. It's sodium hydroxide, so its equivalence is 1. And then one thing to catch here, remember when we do these sort of problems, our volume must be in liters. So again, just kind of running through where I got these numbers from. We were asked to calculate the molar mass of the acid. Okay, remember, molar mass is found by doing grams over moles. We're told how many grams of our acid we have. So we know to finish this calculation, we need to get moles. So like we talked about earlier, we can plug in moles for molarity and volume. So that's our X, moles of our acid, times its equivalence, because again, I haven't subbed in for the equivalence, is then going to equal MEV for our base. So we do our math here. So 0.4 times 1 times 0.02, divide by 1, and I get my moles of my acid, equaling, with the right number of sig figs, 0.00800 moles. And so that tells me how many moles of my acid we have. But we're not done. Now we need molar mass. Okay, so remember, to get molar mass, we take the corresponding number of grams, divide it by the corresponding number of moles. So 0.481 grams divided by 0.008 moles. And that's going to my calculator. And I think we should have 3 sig figs on this. My molar mass would be 60.1 grams per mole. All right, that was 1. Don't worry, I'm going to go through most of this page together. So let's try number 2. So number 2 is asking, what mass in grams of KOH will be required to react with 100 milliliters of 0.5 molar H2SO4? So in this case, we're asking about the base. So that means we just substitute in moles on the base side of our formula. Because again, look at what we're given. We're given volume and molarity of the acid. So we know M, A, and VA. So we know that the molarity of our acid is 0.500 molar. It is sulfuric acid. It's diprotic, 2 hydrogens. Boom, right there. And then again, volume needs to be in liters. So I divide by 1,000 to change milliliters to liters. And then I set that equal to the base side. And again, I'm going for my mass right there. That's what I'm solving for in my my expression. I want grams. So I know my first step is I need to get moles. So again, when we're dealing molar mass in moles, we can sub in moles of our base for molarity times the volume, and then we have to make sure we plug in our equivalents. So instead of being MEV on the base side, remember, just be moles in place of molarity times volume. So just moles times equivalents. So let me do my math here. So 0.5 times 2 times 0.1 divided by 1. Okay, so it's just going to stay the same. So that tells us the moles of our base that we have in our solution was 0.100 moles. And now I want to change that to grams. So this is just one of those normal mole conversions. So 2 ways I could do this. I could plug it up into my expression. I know my substance is KOH, so I could find the molar mass. I could plug in moles and solve for grams. Or at this point, we could just do a mole conversion. So again, we know with conversions, write that over 1. Get rid of moles, change to grams. Oh, that's our molar mass. So I go to my periodic table. I add up 1K, 1O, and 1H. I get that molar mass of 56.11. So I do my conversion, 0.1 times 56.11 grams over 1 mole. And I get my answer of 5.61 grams of KOH. Again, I'll make sure we come back to one of those. We'll do a couple more of those. I think these are a little bit more tricky than the first type, just again because we solve for moles and we have to do that conversion. But let's try another one. So number 3, if 0.25 grams of a monoprotic acid are neutralized with 25 milliliters of 0.5 molar NaOH, what is the molar mass of the monoprotic acid? So as I look at that, it's asking for molar mass of the acid. So that tells me I'm going to do my substituting on the acid side. So again, it's molar mass of the acid. So that means I'm going to plug in on the MEV side for the acid. I'm going to plug in moles. So moles gets plugged in, but I still need my equivalence. It's monoprotic. So E would be 1. And then I'm still going to do MEV for my base. Remember, when we do this substitution, we only plug in moles for molarity and volume on the side we're looking for. And we're looking for the acid. Again, we're looking for the molar mass of the acid. So our molarity of the base, 0.500 molar. It's NaOH, so its equivalence is 1. And then again, the volume needs to be in liters, so I should take 25 milliliters and divide by 1,000. So let me do my work here, 0.5 times 1 times 0.025. And I get my moles of acid. What's going on here? That was crazy. I'll just leave it as being 0.0125 moles. Yep, that checks out. And then again, to finish this problem, remember, to find the molar mass, it is grams that we found or given divided by moles that we calculated. So to finish this problem, to finish our molar mass, I'm going to do it down here. We're told we have 0.250 grams divided by the number of moles we just calculated. So 0.25 divided by 0.0125. And again, with the correct number of sig figs, I think we should have 3 of them. We come up with an answer of right at 20.0 grams per mole. Let me put that on the paper, grams per mole. And to answer the question, that would be HF. All right, so we've kind of gone through a couple of these problems at this point. Might have been a bit rushed, but remember with videos, you can always pause and rewatch or go back through. Let me go through just one more of these. All right, number 4. In number 4, we have a solution with a diprotic base with a molar mass of 58.33 grams. We're told that it takes 32.20 milliliters of 0.125 molar phosphoric acid to neutralize that base. Determine the mass of base in the original solution sample. So again, we're talking molar mass, we're talking grams of base, so we know it's one of our substitution problems that we have to plug in moles for molarity and volume on one side of MEV equals MEV. And I always like to figure that first. So it says mass of base. So because we're trying to figure out the grams of our base, that's the side we're going to substitute in moles on. So I know as I just kind of set this up, I'd have moles of base times its equivalence, and it tells me it is diprotic. And then on the other side, it should just be MEV for my phosphoric acid. So the M for the acid tells us it's 0.125 molar. There we go. Its equivalence is 3. It's triprotic. And our volume, again, should be in liters. So divide by 1,000 to get 0.03220 liters. So let me do my math. So 0.125 times 3 times 0.03220. Better divide that by 2. And I get that I have my moles of my base being 0.00, and then I think, 3 sig figs, 604 moles of my base. Now, we're not trying to find molar mass in this problem. Remember, we're trying to find grams. So remember, to find grams, what we do is take the moles that we find and multiply it by that molar mass. Remember, we do that conversion where we put moles on the bottom to cancel out, and we put our molar mass on top, because once we get rid of moles, we want grams as our unit. So 0.00604 times 58.33, and I get my final answer of 0.353 grams. Oh, no, maybe 0.352. I was missing, not looking at the right number. So 0.352 grams. So there's one more on here. See what you can do. Maybe pause the video, try to set it up and solve it, and then my work will be on here in just a couple of seconds. So again, if you haven't paused the video, pause it, see if you can set up number 5, and then here I go. So we're number 5. We're trying to determine the mass of the acid. So that tells me M and V get substituted for on my acid side. So I'm going to set moles of acid times the equivalence. Again, we always have to make sure we put the equivalence back in with the moles. And that's going to equal to our molarity of the base times its equivalence. It's KOH, that's 1OH, times its volume. And why do I have 0.002450? Remember, volume must be in liters. So we can take ml, we can take milliliters, and divide by 1,000. So to do our work, 0.1 times 1 times 0.2054, then divided by 2, and I get that I have 0.00123 moles of our acid. But then again, I'm looking for not the molar mass, I want to know just grams of the acid in the sample. So this is like problem number 4. I want to go ahead and cancel out moles and multiply by that molar mass in my final step to get my answer. 0.00123 times 62.03, and I get my final answer of 0.0763 grams of my acid. Now you are going to do some more work with this tomorrow. Don't worry, I'll make a little help video for page 21. And if you have questions, you can always email me personally. You can email your own chemistry teacher. You can leave comments. These are all different ways to communicate things that you might want me or any other teacher to go over with you.